Hey guys, we're here to talk about conditional probability, so let's get started. Conditional probability is basically where the outcome of an event is dependent upon the outcome of another event. Okay, so here's the formula for conditional probability, and this is typically referred to as dependent probability because the probability of one event is dependent upon the probability of another event. So the way that you read this formula is the probability of A given B. We want to find the probability that a student chosen at random likes apples given that they like bananas. So over here to the left is our Venn diagram that represents the sample space. A represents the students that like apples and B represents the students that like bananas. So we are finding the probability of A given B. So we have to do the probability of the intersection divided by the probability of B. So I end up with 14 over 100 divided by 32 over 100. And then remember to apply your fraction operation rules. So we have to multiply by the reciprocal. We can cross out the 100s. And so we end up with 14 over 32, which is the same as 7/16. So the probability that a student likes apples given that they like bananas is 7 over 16. Now let's find the probability that a student likes bananas given that they like apples. So this is the probability of B given A. Notice that the order of the letters changes, which changes how your formula will look. So now we're dividing the probability of the intersection by the probability of a student liking apples. So that's going to be 14 over 100 divided by 36 over 100. And so again, we multiply by the reciprocal, cross out the 100s, and then we end up with 7 over 18. As always, if you have any questions, make sure you write them down in your notes so we can discuss them in class. Example 2. There are 62 teachers working at a local elementary school. 33 drink juice, 25 drink soda, and 12 drink neither juice nor soda. So we need to figure out how many drink both juice and soda. Well, we need to recognize that the sample space is 62 teachers. And what they did not tell us is how many teachers like both juice and soda. So we have to fill in our remaining values by subtracting x from 33. We get the teachers that like just juice. And then if we subtract x from 25, we get the teachers that like just soda. Teachers that drink neither juice or soda are 12. So remember, all the numbers in your Venn diagram have to add up to your sample space. So we set up our equation to say 33 minus x plus 25 minus x plus 12 equals 62. Combine like terms, subtract 70 from both sides of our equation, and then divide by -1. We get x is equal to 8. So that's how many teachers drink both juice and soda. So by filling in my x into my expressions, these are the values I will get from my Venn diagram, and so we'll proceed. So one teacher is chosen at random. Find the probability that she drinks juice but not soda. So this is the probability of J intersection the complement of S, which is 25 over 62, because that's this region here. They drink juice but not soda. So that's going to be just the 25. Because remember, if you do all of J, you're also including the teachers that drink soda. We want the teachers that drink just juice and not soda. So again, 25 over 62. Okay, so one teacher is chosen at random. Find the probability that if she is a juice drinker, she is also a soda drinker. Okay, so this is a conditional probability. And so based on this statement, we know that if she is a juice drinker, she is also a soda drinker. So this means that the soda drinker part is dependent upon the fact that she drinks juice. So it's going to be the probability of S given J. So we have to do the probability of the intersection over the probability of J. And so we get these values here. Remember to apply your fraction operation rules. And so we end up with 8 over 33. So one teacher is chosen at random. Find the probability that if she is a juice drinker, she does not drink soda. So we know that we want to find the probability that she does not drink soda given she is a juice drinker. So that's going to be the complement of S given J. So we need to find the probability of S complement intersecting J, which is actually the same as J intersecting complement of S. We just found that probability at the beginning of this particular example. So that's going to be 25 over 62 divided by 33 over 62. So when we apply our fraction operation rules, we see that we can cross out the 62s and we're left with 25 over 33. So the probability that she does not drink soda, given that she is a juice drinker, is 25 over 33. All right, so let's look at example 3. For events A and B, it is known that, and so they give us the probability of the intersection of the complements, the probability of A, and then the probability of B. So these are the 3 pieces of information we need to find. So let's start with A. So in order to calculate the probability of A intersection B, we have to remember that the general probability formula for 2 events, because that's the only way we'll be able to calculate this probability, because based on the information they gave us, there's nothing here that tells us about the intersection for A and B. So we need to use this formula. But then the issue with this particular formula is that we don't know anything about the union between A and B. So based on that, we need to find the union or the probability of the union between A and B. So one important thing to note is that the probability of the complement of A intersecting the complement of B is that that's actually the same as the complement of the union between A and B. So we have to go back and look at the complement formula, which will help us find the union of A and B, which will lead us to the intersection of A and B. So we need to calculate this value here. So by substitution, we get this formula here. So I substitute in the 0.35 and subtract it from 1, and I see that the union of the probability of the union of A and B is 0.65. So now let's substitute our known values into the formula and solve for the intersection. So I plug in what I know, I combine like terms, then I subtract 0.85 from both sides of my equation, and then divide by -1. So the probability of the intersection between A and B is 2/10. Okay, let's look at part B. We want to find the probability of A given B. So we just calculated the intersection between A and B, and we already know the probability of B. So we just plug in our values and then simplify. In decimal form, you'll get that this conditional probability is 0.33 repeating, which is the same as 1/3. As always, if you have any questions, make sure you write them down in your notes so we can discuss them in class. Okay, so let's find the probability of the complements. So the probability of A complement given B complement. And so we actually have all of these values here as well. So all we have to do is plug in our numbers into our equation and then simplify. So as always, if you have any questions, make sure you write them down in your notes. Thanks for watching.